Welcome to yet another lesson on a topic in Mathematics Form 4 known as matrices and transformation. To be specific, we will be covering shear transformation, and without much ado, kindly allow us to dive in and discuss in detail what is shear transformation. So what is shear transformation? Under a shear transformation, the object points move parallel to a fixed line called the invariant line. What is an invariant line? We'll see in a few what is the invariant line, but it is worth noting that the points on the invariant line are unmoved. That means they don't shift from one position to another. Remember, a transformation is simply the process where we change either the orientation, the size of an object. Let us go through few notes, few NBs that we need to take into consideration before we discuss this subtopic known as shear transformation in detail. Note number one is that all the points that are not in the invariant line must move parallel to the invariant line. What do I mean? Look at our diagram here. We have a rectangle A, B, C, D that has undergone a shear transformation into A prime, B prime, C prime, and D prime. Remember, we have said that the object points move parallel to a fixed line that we call the invariant line. So what is our invariant line in this particular diagram? The invariant line must be the x-axis. The reason being, the points on this particular line remain unmoved. That means they don't move. And it is evident from the diagram that we have a point A where the image point is formed on the same spot. Even point B is still formed on the same spot. And we have a point D and C that seem to be moving in a direction that is parallel to the invariant line. Let's look at in a scenario whereby the invariant line is y-axis. A, B, C, D, and we have point C and B that is moving in a direction that is parallel to the y-axis. Remember, the y-axis in this particular diagram is the invariant line. Note number 2 is that each line on the object parallel to the invariant line intersect or meets with the image at the invariant line. This one is very evident with this particular example where we have point A and A prime. They are meeting on the invariant line. We have point B and point B prime, which are also meeting on the invariant line. NB number 3, a shear transformation does not change the area of the image, thus the area of the object is equal to the area of the image. Describing a shear transformation. A shear transformation is described fully by stating two things. 1, stating the equation of the invariant line. 2, stating a point not on the invariant line and its image. So the invariant line comes in 4 forms. We have A, B, C, D. In A, x-axis invariant. X-axis invariant, or y equal to 0 as the invariant line. So we have an identity matrix in this case, 1, 0, K1, where K is the shear factor. In a diagram, it will appear like this one. We have a rectangle here that has undergone a shear transformation into this shape, and kindly note that in this case the x-axis is the invariant line. We have points on the image that seem not to be moving, but on the other side the points that are not on the invariant line are moving in a direction that is parallel to this line that you're calling the invariant line. So this is x-axis, or y equal to 0 as the invariant line. Second, y-axis, or x equal to 0 as the invariant line will look like this. have a matrix of transformation 1k 0k as k as the shear factor, remember, and in a diagram we have this rectangle that has been transformed to this. Kindly note that we have the point D prime, A prime. These 2 points that are on the invariant line are unmoved, and we have the other points that are moving in a direction that is parallel to the invariant line. So you give, for you to fully describe this type of transformation, you give the y-axis as the invariant line, then you choose a point on the diagram here, maybe C to C prime or B to B prime. You state that point and you'll have fully described this type of transformation. C, y equal to B as the invariant line, where B is the y coordinate. And in a diagram, it will appear like this one. We have that one, and the y here, y equal to 2, is the invariant line. But D, x equal to B, where B is the x coordinate. And in a diagram, we have an illustration. This is x equal to 4 as the invariant line. Q prime, R prime are not moving, are on the invariant line because points on the object that are on the invariant line do not move. But on the opposite side, we have the points that are not on the invariant line. They move in a direction that is parallel to the invariant line as seen here. P to P prime, S to S prime. Lastly, you state a point on the invariant, not on the invariant line, and its image. Let's say D14 mapped to D74. And in a diagram, you state a point like this one here. Like the first example, you can decide to state this point here. You say we have 24, S24, and S prime 28. You give that point, then you give the x equal to 4 as the invariant line, and you will have fully described that type of transformation. So that is the end of the first lesson. We'll meet in the second lesson, where we shall discuss the shear factor and how to calculate the shear factor into detail. And if you've liked this video, kindly like, subscribe, and say a word. We'll meet in the next lesson.